Having already studied increasing annuities, let's take a look at decreasing annuities now. So the idea is, again, that you will be making regular payments of a fixed amount, for example, in this problem, $1,000 every month, except these payments will decrease a balance instead of increasing the balance. For this problem, you're withdrawing money from the bank, so you can think of this as the bank making payments out of your account. So every time you withdraw $1,000, the balance decreases. Now, compensating for that somewhat is the fact that this account is earning interest, a 6% interest, and we say that when we just say 6% interest, we mean annual interest, so we have to calculate the periodic interest from that by dividing by 12 for monthly compounding. Now we imagine we have, say, a retirement account and we want this savings to last 10 years. How much money do you need to start with so that $1,000 a month will last 10 years while gaining interest? You do not need to take 10 times 12 times 1,000. That would be too much because you're not taking advantage of the interest in that calculation. So let's see how we could actually figure this out. The periodic interest rate, the amount of interest you get each month, is the annual rate 6% divided by 12. So that's going to be 0.005. And imagine that instead of just having one account with all the money, you'd separated the account into 120 separate accounts. So the first account, you're going to withdraw all of the money from it when you make your first withdrawal at the end of the first month. And then when you make your second $1,000 withdrawal, that will empty the second account. Exactly empty it. And so on. So how much did we need to start with in each of those accounts? If we started with P1 in the first account, P1 represents the starting balance of the first account which we empty at the end of the first month. At the end of the first month, it has $1,000 in it, which means at the start of that month, it had P1, and we multiplied it by 1.005 to represent the 0.5% periodic interest rate. And we can use this information to isolate P1. We can just divide both sides of this equation by 1.05, which is what we did here. So remember, this negative 1 exponent is equivalent to a reciprocal, so this was another way of writing 1,000 divided by 1.005. Okay, so this is the idea. I imagine that I put some money into the first account, and it's just enough so that at the end of 1 month, it's $1,000. This is how much money I need to put into that account at the beginning so that it'll be $1,000 at the end. How much money do I need to put into the second account? So the second account is going to start with an amount we can call P2. It's going to gain a periodic interest rate twice, so that's why I'm multiplying by 1.005 squared, because it's going to gain interest for 2 months. At the end of those 2 months, we'll have a total of $1,000. So I can solve for P2 out of that equation. I could do the same thing for any other month. Imagine I put aside a little bit of money, and after n months I can withdraw exactly $1,000. Then the amount that I had to put away to achieve that is given by this formula. So the total amount of money I need to put away for the savings goal is the sum, how much I put away so that I could withdraw 1,000 at the end of the first month, plus how much I put away in order to be able to withdraw 1,000 at the end of the second month, and so on for 120 months, 10 years. So I can write out each of those using the formulas that I came up with earlier. And notice that this looks like a geometric sum. In fact, after I factor out the greatest common factor, what's left here matches a geometric sum. And so I use the geometric sum formula to simplify all those values added together. And this is now something that I can punch into a calculator and get a result. So it turns out for 120 months, $1,000 a month, I do not need to put away $120,000. A little over $90,000 will be sufficient because I'm going to benefit from interest accumulated along the way. Okay, so let's see if we can turn this into a formula. This kind of calculation that we just performed can be used to describe any sort of decrease in annuity where you have regular payments that decrease the balance over time. Those are called decreasing annuities. And so another example would be something like a car loan, and we'll see examples of that in later videos.